Hello. Now here we have quadratic function represented in different forms of its equations. Now as you know, a quadratic equation could be in the standard form ax squared plus bx plus c, or in factored form x minus a times x minus b, or in vertex form ax minus b whole square plus q. Now the question here is, what features of the graph of quadratic function are most easily determined from the function in these forms? Correct. So let's try to think and list which forms give us which kind of information immediately. I mean to say, you don't really have to do many calculations, but when you look at it, you get that information. This is kind of a very important exercise because it helps us to understand the equations better. Now here, let's see the first one, which is the standard form. Now imagine that x is 0, correct? If x is 0, then what will be the value of this function? So let's write this as f of x. What is the value of f of 0 here? So if I plug in 0 here, I get c, correct? And what is c that means? So at x equals to 0, whatever value you get is actually the y-intercept. Is that okay? So y-intercept is very easily seen from the equation in standard form. I hope you appreciate that part. And second is the a value. So a value, you know, if a value is greater than 0, that means positive, then the parabola will open up, right? And if a is less than 0, then it open downwards. Is that okay? So these three things are obvious when we look at this equation, correct? Similarly, now let's look into the factored form. The factored form is a very good equation if we have to find the x-intercepts. So at x-intercepts, we get f of x equals to 0, right? So if I equate this equation to 0, I know the points where it will give me 0, right? So those are the values at x equals to a and at x equals to b. So this equation gives me x-intercepts. So I'll write x-intercepts. Now, what else can it give you? Can it give you axis of symmetry? Well, now those points need some calculations, right? So let's see what calculations are needed to give other things which are not very difficult actually. So when you have x-intercepts, then the middle value, which is at x equals to a plus b divided by 2, we get axis of symmetry. Correct? So it does give you axis of symmetry. And now, if you plug in that value, we can also find the maximum minimum value or the vertex. Correct? Let me go back to this. Standard form. Here also you can get axis of symmetry, and here how will you get axis of symmetry? You'll find that when you do completing the square, you have to half this term, right? Plus and minus square of that, right? So this term minus b by 2a is the axis of symmetry, is the x point, right? And value of function at that point will give us the vertex. So you can calculate, right? But the idea here is, what can you immediately see and find? So I'm not really listing them here, but they are like not so difficult to figure out. Therefore, I'm mentioning them very clearly here. Correct? Now, in this form of equation, this is called the vertex form. So obviously, from here you get the vertex. That is the first thing you get. What is the vertex here? PQ, right? So P and Q becomes the vertex of this. Vertex gives us the point at which you have a maximum. So at x equals to P, we have a maximum value of Q, correct? Yes. And A gives you what? If A is greater than 0, then moves up, right? And if A is less than 0, then it is downwards, right? So it does gives you the direction of opening also. Plus, the vertex form is very good for transformations. So here, there's a vertical stretch by a factor of a, if a is greater than 1. If a is less than 1, then it is vertical compression. If a is negative, then it is reflection on x-axis. And this p, if it is positive, it is p units to the right horizontally. P is negative, then p is p units to the left horizontally. Translation, right? And q is a vertical translation factor. I should not use the word factor. Factor is multiplication. So q gives you how many units the graph moves up if it is positive and down if it is negative. So those are the vertical transformations here. Now when I have written vertex, it means that we do get axis of symmetry, minimum maximum value, and the point at which we have a maximum or minimum value. Correct? So these are things to remember when you have a quadratic function in all these forms. Correct? Now, you can see how difficult it is from vertex form to find the y-intercept. Do you see that? Y-intercept will mean that you can plug in x equals to 0, right? And then you calculate, correct? So the calculation is required. So it's not that easy, correct? That way we can also find y-intercept here, because y-intercept is what? A times b, right? If I put 0 here, but needs small calculation, x equals to 0, y-intercept as such is not a very difficult point, but the thing is, that calculation is not required in standard form. How would x-intercept? If you have to find x-intercept, what will you do with this equation? You'll use the quadratic formula, right? You say minus b plus minus square root of b square minus 4ac divided by 2a. It's a lengthy formula. Then you find the x-intercepts from this standard form. And how about this equation? It's even tougher. You say, because at least there is a formula to calculate, right? And in this case, what do? You equate to 0, right? Because at x-intercept, f of x is 0. And then you bring q to that side, then you divide by a, and then you square root with plus and minus, and then you add p, kind of. You derive that formula, right? So there are so many steps taken. Therefore, we see that different forms can be used in different ways, and we should try to use them in the best possible way. Okay? I hope you appreciate why we have so many different forms and how do they help us. Okay? Thank you.